Good day to our project development instructor, Engineer Myrick Ichirado, to the panelists, Campus Dean Dr. Michael Flores, Engineer Gerardo Cipres, and Mr. Ramil Del Fuente. I am Christian T. Sancha, and I would like to greet you all a pleasant day. We will be presenting a proposed study entitled Design and Fabrication of Wind-Powered Battery Charger for Motorboat Engine, together with my group mates Mr. Kim Fernando, Miss Pia Flores, Miss Elma Flores, Miss Dailin Berha, Miss Kathleen Breeze, and Mr. Will Delenya. For the background justification of research, here is Mr. Kim Fernando.
Yan ang nasalaan.
Yeah. Oh.
Background justification of research. Over the years, the ability of people to adapt changes has brought too many developments, especially in terms of electronic and industrial aspects. These changes in technology can be attributed to the inventive activity of mankind. And oftentimes progress, as many have believed, are defined in terms of ability of people to invent new product and processes. In this time of modern technology, the need to invent more product would also mean the need to raise global concern in environmental protection. Thus, clean energy resources attract more attention nowadays, such as solar energy, wind energy, wave energy, thermoelectric energy, and kinetic energy. This is to ensure the protection of our Mother Earth despite the invention on the use of different materials that emit fuel and contribute to population and other environmental problems. Gorso, 2014, pointed out that technologies and materials are advancing in a way that sailboats using solar wind energy are eco-friendly, thus making them sustainable than of transportation. Hence, solar and wind-powered engines are introduced to help those in ma- maritime industry. In everyday life, transportation is highly needed. May it be land, water, or air transportation. One of the innovations that can be seen today is the use of hybrid electric vehicle in some progressive countries that are more energy sufficient and environment friendly. There are also solar powered vehicle and other devices that use renewable energy. Hence, hence this proposed study. May, Here is Miss Pia Flores for Rationale.
Rationally, renewable energy use has become a trend in automotive and maritime industries as alternative way to combat greenhouse effect brought by fuel or gas emission of hydrocarbon burning fuel engines. In the Philippines, access to clean energy are considered impediment to sustainable developments, particularly in underprivileged and remote areas, where small islands are not supplied with electricity. Although government aimed to achieve universal electrification by 2022, this led the way to the use of renewable energy in these islands, with the help of some private firms that work hand in hand with local government units and government agencies. Likewise, those in the maritime business are now committed and open for various innovations, that have taken place to address this problem of relying on the fuel consumptions in maritime vessels. The coastal communities, particularly the remote and inland folks, have experienced the rising fuel costs and other challenges that affect their livelihood, and the shift to renewable energy is seen as motivation to shift to the use of solar and wind-powered engines. But in this part of Bicol region, especially in Caramo and Camarines Sur, it is seldom or to some extent not totally using these renewable energy sources, especially in water vehicles like motorboats. It is in the premise that the researchers propose the use of wind-powered battery charger for motorboat to help fishermen as well as other motorboat users to become environmental friendly.
Thank you, Ms. Pia Flores. Significance of the study. This study is deemed beneficial considering that the shift toward achieving eco-friendly environment is very important. Among the beneficiaries include automotive students because the result of this study will serve as avenue for invention or research and development and also improving their creativity and help them to apply the concept that they have learned in the course. Similarly, instructors are benefited since it will serve as output in the course to improve the teaching learning process. Further, it will also help the university in the community as it will help it ultimately achieving safer environment.
This study is concerned with the design and fabrication of wind-powered battery charger for motorboat engine. To realize this, the study has the following objectives. Number 1, design a wind-powered battery charger for motorboat engine. 2, identify the materials to be used in developing the with wind-powered battery charger for motorboat engine. 3. Determine the level of acceptability of wind-powered battery charger for motorboat engine terms of fun- functionality, efficiency, cost effectiveness, and user.
For the methodology, this study will use a descriptive method in order to determine the wind-powered battery charger for motorboat engine. The researchers gathered related literatures and related studies from the internet. The researchers formulated questionnaires for validation and revised for the contribution of the survey questionnaires to the respondents of this study. The researchers will distribute the survey questionnaire to tabulate, organize, and interpret the data from the retrieved researchers made survey questionnaires from the respondents. Statistical tools will be used. The instrument used in gathering data in this research will be survey questionnaire. The researchers prepared a survey questionnaire provided to the respondents to get the data on the acceptability of the wind-powered battery charger for motorboat engine in terms of functionality, efficiency, cost-effectiveness, and user-friendliness. The respondents of the study will 20 Bachelor of Engineering Technology students, major in automotive, 3 instructor of automotive technology of Partido State University, 5 motorboat owners, 5 boatmen. This study will use the descriptive method to determine the wind-powered battery charger for motorboat engine. Model of the system components. A wind power generation system consists of wind turbine, battery bank, inverter, controller, and other accessory devices and cables. To predict the performance, individual components will be modeled first. Wind turbine performance model. Choosing a suitable model model is very important for the wind turbine power simulations. For a typical wind turbine, the power output characteristics can be assumed in such a way that it starts generating at the cut and wind speed. The power output increases linearly as the wind speed increases from Vc to rated wind speed Vr. The rated power PR is produced when the wind speed varies from the Vr to the cut out wind speed Vf, at which the wind turbine will be shut down for safety considerations. For small scale wind turbines, the cut in wind speed is relatively smaller and wind turbines can operate easily even when wind speed is not very high. Battery performance model. Lead acid batteries used in hybrid solar wind system operate under very specific conditions, which is often very difficult to predict. Usually, a lead acid battery is mainly characterized by the stage of charge, SOC. For a perfect knowledge of the real SOC of a battery, it is necessary to know the initial SOC, the charge of discharge time, and the current. Relatively model based on LPSP concept. Loss of power supply probability, or LPSP, is defined as the probability that sufficient power supply results when the hybrid system, PV array, wind turbine, and battery storage is unable to satisfy the load demand. LPSP is equal to summation of T power fill time P supplied T P needed T is equal to 0, where N is the number of time intervals, the number of hours in the study will early weather data input. Economic model based on ACS concept, the economical approach. According to the concept of annualized cost of system, ACS is developed to the system cost analysis. ACS is equals to C ACAP equals annualized capital cost, C RF annualized replacement cost, and C main annualized maintenance cost.
Data gathering procedure. The researchers gathered the related literatures and related studies from the internet. The researchers formulated questionnaires for validation and revised for the contribution of the survey questionnaires to the respondents of this study. The researchers will distribute the survey questionnaire to tabulate, organize, and interpret the data from the retrieved researchers' made survey questionnaire from the respondents' statistical tools will be used. Project performance analysis with field measured data. A time series data of the project will be recorded for 3 months. The weekly energy contribution of the wind turbine, the battery working states, and the energy balance will be investigated. Weekly energy contribution of the turbine. Weekly analysis of the hourly measured field data will be done to show the energy contribution. A graph will be generated to show the weekly contribution in relation to the weekly average power in watts. Energy balance on the battery. Most storage systems are not ideal. Losses occurs in charging and discharging cycles and also during storing periods. The total energy efficiency of the battery is the ratio of the energy obtained during this charging process to that required to restore it to its original condition, and can be expressed by Jusen et al.
Statistical tools. The statistical tools to be used will be weighted mean to describe the average of the score by the respondents. Mean variable will be used. Formula. Weighted mean equals the summation of frequency times class mark divided by the population or total. where x is equals to weighted mean, f equals frequency, x is equals to class mark, n is equals to total population. To determine the level of acceptability of the device, the researchers will make use of the rating scale below. Points and description. 5. Highly acceptable. 4. Acceptable. 3. Moderately acceptable. 2. Fairly acceptable. And 1. Unacceptable. Local of the study. Research expected output, patent intellectual property, proprietary invention of scientific process for potential future profit. Estimated budget, items and particulars amount, generator 300 pesos, wire 90 pesos, charge controller 300 pesos, main switch 50 pesos, spray paint 240 pesos, alligator clip 55 pesos, voltmeter 250 pesos, indicator light 10 pesos, fuse 15 pesos, connector 130 pesos, welding rod 150 pesos, propeller 100 pesos, welding machine for rent 150 pesos, electric drill for rent 100 pesos, grinder for rent 100 pesos, soldering iron for rent 50 pesos, soldering lead 50 pesos, labor 500 pesos, electric consumption 100 pesos, subtotal 2,840 pesos.
Pag matapos yun eh, kung parang bagos?
Literature cited. Gorso H. 2014. Solar and wind powered concept boats. The example.
Patron mo. Sige, tararam.
Ulit ka.
Sige na.
Ina. Literature cited. Gorso H. 2014. Solar and wind powered concept boats. The example of Boletan Virtue P. 2010. Supplying not electrified islands with 100% renewable energy-based microgrids. A geopastal and techno-economic analysis for the Philippines. Energy 202 117670 Nieves de Selva, CA and Connors S. 2014. Design and implementation of hybrid renewable energy systems on microcommunities. A review on case studies, renewable and sustainable energy reviews, 31,935/946. Martin Hens 1, George D. Wade 1, Anand Sundaraman 1, Evan Lowell 2, Eric K. M. Yee, 2015. Solar-powered sailing yacht in the tropics. Matsushima T. Takagi, S. and Murayama S. 2006. Characteristics of highly efficient propeller. Type small wind turbine with a diffuser. Renewable energy 319 1343/1354 https://do.organization10.1016 g.rename.2005.0.7.008. Okay, basta talaga ito. Where T 2018 Renewable Energy in the Pacific Islands, its roles and status. Renewable and Sustainable Energy Reviews. 94,762-771 at https://dot.org/10.1016/j.arcer.2018.05.069. Zia B, Jen M. J., Shen J.X., and Sang A.G. 2010. Design and Analysis of an Air-Cored Axial Flux Permanent Magnet Generator for Small Wind Power Application. 2010 IEE International Conference on Sustainable Energy Technologies at ICCSEP 1 to 5 https double dot slash story.org slash 10.1109 slash ICSET dot 2010 dot 5684427. Yamamura N., Ishida M., and Hori T. 1999. A simple wind power generating system with permanent magnet type synchronous generator. Proceeding of the IEE 1999 International Conference on Power Electronics and Drive Systems. FEDS 99 CAT that number that 990H8475 849-854 Volume 2 https double dot slash doi.org slash 10 dot 1109 slash pids dot 1999 dot 792817 Yang, H. Wei, Zhe, and Shengzi, L. 2009. Optimal Design and Techno-Economic Analysis of a Hybrid Solar Wind Power Generation System. Applied Energy 86 to 163/169 https double dot slash doi.org slash 10.1016 slash ga upenergy dot 2008.03.008. Prepared by Kathleen S. Bress, Bet MD Trivia Student, Dylan A. Prepared by Kathleen S. Bress, BetMed Trivia Student, Dylan A. Berha, BetMed Trivia Student, Elma A. Flores, BetMed Trivia Student, Pia D. Flores, BetMed Trivia Student, Roel De Lina, BetMed Trivia Student, Kim Z. Fernando, BetMed Trivia Student, Christian T. Sancha, BetMed Trivia Student Project Leader. Noted, Myrek Echurado M.A. Project Development Instructor, Raul B. Borse, MSc, Research Coordinator. Recommending approval, Michael A. Flores, PhD, Panel Member, Ramel C. De La Puente, Panel Member, Engineer Gerardo A. Sepres, BetMed Program Chair, Chairman of the Panel. Approved by Michael A. Flores. Thank you so much.